Imagine Rome not as a city of torches, but as a city learning to command invisible power. In this alternate timeline, the first discovery is not a miracle. It is a chain of experiments with copper, acid, motion, and patience, hidden inside workshops that look ordinary until the lamps begin to glow. The breakthrough begins with practical people, not modern scientists. Metal workers notice strange shocks from stacked plates. Engineers repeat the effect. Philosophers argue about its meaning. By the time senators hear rumors of controllable light, the empire already has artisans who can produce weak but repeatable current on demand. At first, electricity changes the night. Temples, baths, archives, and ports gain small pools of steady light. The city does not become modern overnight, but darkness loses some of its authority. Work stretches later. Messages can be read after sunset, and power starts to look like infrastructure. The workshops become the true laboratories of the empire. Copper coils are wound by hand, clay jars become batteries, and water wheels turn crude generators. Nothing is efficient yet, but Roman engineering has one enormous advantage. Once a method works, the state knows how to standardize it. A single invention matters less than the network around it. Roads carry components, ports move copper, aqueducts provide mechanical force, and scribes preserve procedures. Electricity becomes another imperial system, like law or taxation, built through repetition, measurement, and bureaucracy rather than sudden genius. The first electric machines are fragile. Coils overheat, jars leak, lamps fail, and officials complain about cost. But the empire is already used to building expensive public works. If a bridge can justify its stone, a signal tower can justify its copper when it saves days of uncertainty. Communication changes before warfare does. Along the frontiers, signal stations use flashes, shutters, and coded pulses to move information from hill to hill. A border report that once needed a rider in a week can now reach a provincial office before the weather changes. That detail matters because it turns the scene from a visual idea into a clear cause and effect in the alternate timeline. This does not make Rome all-knowing. Storms interrupt signals, sabotage is possible, and local commanders still interpret events badly. But the rhythm of empire speeds up. Governors receive instructions sooner, merchants trust schedules more, and distance becomes a little less powerful. That detail matters because it turns the scene from a visual idea into a clear cause and effect in the alternate timeline. The social effects arrive quietly. The people who understand coils, switches, glass, and insulation become valuable. Some are citizens, some are freed workers, some are provincial specialists. A new technical class grows inside a society that was never designed to reward technical knowledge fairly. In the streets, electricity becomes a symbol before it becomes common. Wealthy houses show illuminated courtyards. Public buildings display controlled light during ceremonies. Ordinary workers see the promise, but also the inequality, because every new system first serves the people who can pay for it. The empire now faces a question every technological society eventually faces: who owns power? If electricity belongs only to temples, palaces, and military depots, it strengthens hierarchy. If cities build public workshops and schools, it begins to spread skill beyond the old aristocratic families. That tension drives the story forward. Some senators fear that trained mechanics will become politically dangerous. Others see profit, prestige, and administrative advantage. The debate is not about whether electricity works anymore. It is about what kind of civilization should be allowed to grow around it. Industrial sites become the testing ground. Water wheels spin more than grain mills. They turn early generators, power simple tools, and illuminate dangerous work areas. Production improves, but the moral question sharpens. Technology can reduce hardship, or it can make extraction more efficient. In this timeline, reformers argue that electrical systems require trained operators, maintenance records, and safer procedures. That pressure does not end exploitation, but it creates new rules. Machines are too valuable to be run by chaos, and skilled labor becomes harder to treat as invisible. The empire begins documenting accidents, failures, and repairs. Manuals travel with components. Provincial workshops copy diagrams from Rome, Alexandria, Antioch, and Carthage. The most important invention may be administrative memory, a way to prevent every generation from starting over. Inside the Senate, electricity becomes philosophy with a budget attached. Priests ask whether artificial light trespasses into divine territory. Merchants see new markets. Engineers want funding. Conservative families fear change. The argument sounds ancient, but the pattern is familiar to every technological age. The strongest opposition is not ignorance, it is fear of redistribution. If provinces can build their own electrical networks, Rome loses some monopoly over expertise. If technical schools expand, status begins to shift from bloodline toward competence, and that threatens people who benefit from the old order. Still, the practical benefits are too visible to suppress completely. Better lighting protects warehouses. Faster signals reduce panic. Standardized measurements improve construction. The empire may resist change culturally, but administratively, it becomes addicted to the advantages electricity provides. Maps of the empire start to look different. Not just roads, but routes of power and information connect cities. Relay stations cluster near ports, mines, aqueducts, and administrative centers. Geography still matters, but it is now edited by cables, towers, workshops, and trained maintenance crews. The Mediterranean becomes a networked machine. Grain shipments, tax records, naval warnings, and engineering requests move faster than before. The system is imperfect and expensive, but even partial speed changes political expectations. Once leaders experience faster information, slow government starts to feel like failure. The danger is centralization. An emperor who controls the relays controls perception. Delayed messages can become political weapons. Technical infrastructure does not automatically create freedom. It creates leverage, and the moral direction depends on who can inspect, repair, and challenge the system. Then comes the question of collapse. If Rome still fractures, electricity does not simply vanish. Ruined stations, copied diagrams, trained families, and preserved manuals remain scattered across Europe, North Africa, and the Near East. The fall becomes less like a blackout and more like a damaged network. Monasteries and city workshops preserve fragments differently. Some treat electrical diagrams as sacred puzzles. Others use them for bells, lamps, clocks, and medical experiments. The Middle Ages in this timeline are not modern, but they inherit a technical memory our own history had to rebuild much later. That inheritance changes education. A student learning geometry may also learn circuits. A clockmaker may study Roman coils. A navigator may trust illuminated instruments. Progress is still uneven, interrupted by wars, plagues, and politics, but the baseline of technical curiosity is higher. By the Renaissance, Roman electrical manuscripts become treasures. Artists study light not only as symbolism, but as controllable phenomenon. Inventors combine optics, magnetism, and mechanics earlier. The boundary between workshop, studio, and laboratory becomes thinner than it was in our timeline. This earlier scientific culture does not guarantee a better world. It can produce surveillance, monopolies, and imperial nostalgia as easily as medicine and communication. The central lesson of the alternate timeline is not that technology saves civilization, but that institutions decide what technology becomes. Imagine telescopes improved by steadier instruments, ships guided by better signals, and cities lit by systems descended from Roman mistakes. The modern age arrives with a longer memory behind it. People do not ask who discovered electricity. They ask which empire first learned to govern it. By the end, the skyline is almost familiar, but its ancestry is different. The wires, lamps, archives, and laboratories all trace back to marble halls and copper coils. Rome did not invent the future alone. It merely changed when humanity began rehearsing it. That detail matters because it turns the scene from a visual idea into a clear cause and effect in the alternate timeline. So what if Rome discovered electricity? The answer is not a single gadget or a glowing city. It is a civilization forced to confront power in both meanings of the word. Energy that moves through wires and authority that moves through institutions, laws, and human ambition. That detail matters because it turns the scene from a visual idea into a clear cause and effect in the alternate timeline. The alternate timeline leaves us with a warning and a possibility. Discovery is never enough. A society must choose whether knowledge becomes spectacle, control, or shared capacity. Rome with electricity would not simply be brighter. It would reveal earlier than ever what kind of people held the switch.